Part 6 in the Run Chart video series is regarding types of data. In this next section, I'm going to introduce you to more information about types of data. In particular, this is the type of data that's used in run charts. Interestingly, this is all relevant for if you want to learn more in the future about statistical process control charts. This is all relevant information as we use data about attribute data and continuous data in both run charts and statistical process control charts. When you've collected your data, the next step is to chart it in a run chart. You can either use a template in the quiz system or one of the templates on the CSE Quality Tools webpage. You need to recognize the type of data that you have, and that will determine the template that you use, such as attribute data or continuous data. A run chart enables a team to easily recognize and analyze variation in the data that's not so easily apparent when you just look at the data in a table. I'll now give a detailed explanation about both continuous data and attribute data. Continuous data is also known as variable data. It's obtained by recording a numerical value for each unit observed. It's depicted as either money or time, such as hours, minutes, or weeks, weight, length, temperature, or throughput, such as the number of patients seen in an outpatient clinic. It's a form of quantitative data and can be summarized by calculating the mean, median, standard deviation, etc. It can have a decimal point, in other words, a fraction, and it's used in run charts, statistical process control charts, such as the eye chart and the X bar and S chart. It's also used in scatter plots and in a histogram. So some examples of continuous data in healthcare may include the wait time in minutes to be seen in a clinic or in the emergency department, the wait time in weeks for a community consultation or a clinic appointment or for elective surgery, the turnaround time of test results, such as for pathology or medical imaging, and the throughput or the number of procedures or tests performed or patients treated, say in the community or in a clinic or as inpatients, the number of surgeries performed, maybe the number of babies being born or the discharges from a ward, etc. Other examples of continuous data are like blood glucose readings or blood pressure. Some financial examples are like revenue, expenditure, or operating margins. And another example might be the duration of a consultation or a procedure, such as the length of time of a home visit or the length of time of a particular surgery. Attribute data, which is also known as discrete data, can be obtained by noting the presence or absence of a quality characteristic within a specified number of units. For example, it's the focus on counting either defects or non-conformities. Attribute data is used in a run chart, also a statistical process control chart, such as the C chart, U chart, or P chart, and it's also used in scatter plots. Attribute data can be broken down further into count data, and the data can be expressed as either the count or the number of defects or the rate of defects. It also can be broken down to classification data. That's data expressed as either a proportion or a percentage. So I'll now list some examples of attribute data. And remembering this is a focus on defects or non-conformities in healthcare. So count data would be looking at the number or the frequency or the count of incidents, in other words, defects or non-conformities. So for example, the number of falls or the frequency of needle stick injuries or the number of complaints or the count of pressure areas or the number of failed to attends. Rate-based data looks at the number of incidents or non-conformities per, say for example, occupied bed days, or the number of incidents per 1,000 occasions of service in outpatients, or the number of central line infections per 1,000 line days. In classification data, it's expressed as either a proportion or a percentage. This is where you have a numerator and denominator. And some examples are like the percentage of infections, or the percentage of clinic no-shows, or the percent of hand hygiene compliance, also the proportion of cancellations. We'll now look at some examples of run charts and the types of data that they've used. In this run chart, we're looking at the count or the number of incidents of postoperative bleed per month. So the y-axis is a form of attribute data. It's the count or the number or the frequency of incidents. On the previous slide, we looked at a chart with the number of incidents of postoperative bleed after surgery. The data used in this graph was account data, which is a form of attribute data. So that is the template that you look for in either QUIDS or on the Excel run chart template. All you need to do is key in your data, decide on your stretch goal. The area in grey, you don't need to do anything because that will calculate itself. With these templates, we're also stating the statistical process control chart that is relevant for this data. You don't need to worry about this information at the moment, but it will be of interest later on when you want to do your control charts. In this run chart, we're looking at the fall rate per 1,000 occupied bed days. So the y-axis is a form of attribute count data expressed as a rate. In other words, the fall rate per 1,000 occupied bed days. The way you calculate this is the number of incidents or the number of fall incidents divided by occupied bed days over 1,000. In the previous slide, we were looking at the falls rate per 1,000 occupied bed days. The run chart template that we'd use in this situation is for attribute data, but when you are wanting to calculate a rate. In this next example of attribute or classification data, we're looking at the percentage or the proportion of infections per month. So the y-axis in this case is percent. The previous slide, we looked at the percentage of infections. This is classification data, which is a form of attribute data. So you would use the template where you want to calculate a percentage or a proportion. In this example of a run chart, we're looking at continuous or variable data. The y-axis in this case is minutes or time. We're looking at sepsis patients in the emergency department. And what we're actually measuring here is the minutes from their diagnosis of sepsis to the administration of their first antibiotics. And the patients on the x-axis are seen in chronological order. The previous slide, we looked at sepsis patients and it was using continuous data. You'd therefore look for the continuous data template in either QUIDS or on the Excel run chart template. In this chart, we're looking at the number of home visits per day. This is a form of throughput data or continuous variable data as it's a measure of throughput. So the y-axis here is the number of home visits per day, and we're looking on the x-axis as the day of week. In this next run chart, we're looking at the number of days patients had to wait for their outpatient clinic appointment. So the y-axis is a form of continuous or variable data. It's looking at the days patients waited for their clinic appointment. And on the x-axis is patients in chronological order. In this chart using continuous data, we're looking at the median weekly wait time in minutes from labour ward to the theatre for emergency caesarean section patients. This chart has actually 164 patient observations over the 20 weeks, and that y-axis is looking at minutes waiting time. This is the table from which the chart of the median weekly waiting time for emergency caesarean section patients came from. This table includes 164 patient observations over the 20 weeks of data collection. In week 1 of the audit, there were 9 caesarean section cases observed, and the median wait time for those 9 women was 27 minutes. In week 2, there were 7 cases observed, and the median wait time for those women was 21 minutes. All this information is charted in the run chart, looking at the weeks, the median times per week, and the overall median. When you learn about statistical process control charts, this template is used to create those charts. This is another type of run chart where you're looking at the time between incidents or the days between incidents. So what we're looking at here is the number of days between surgical site infections. It's continuous data, and what we're measuring on the y-axis is days between infection cases. So how it works is along the x-axis is the date that an infection or an incident occurred. And if you measure the days difference between the 3rd of January and the 15th of January, it's actually 12 days. So what's plotted in the chart is 12 days. Then the next case we've got from 15th of January to the 22nd of January, which is 7 days. So 7 days is plotted on the chart. What's interesting with this chart is we're looking at incidence, but the desired direction of the data is actually up because we want to have many days between incidents. This converts to a T-chart when we start to learn about statistical process control charts. And it's a very good chart for rare events. And this is the template that you would use if you wanted to chart some information around the time between incidents. You'll need to do a manual calculation to determine the time between the incidents in the column below. This is another type of run chart. It's very good when you have rare events. It's also continuous variable data that's used in this. So this is the number of surgical cases or surgical operations between infections. So what we're looking at on the y-axis is the number of surgical cases, and on the x-axis we're looking at the date of the infection was reported. So between the 8th and the 19th of January, there were 25 operations between that time. So 25 is plotted on the chart. Between the 19th and the 24th of January, there were 32 operations. So the 32 operations are logged onto the chart. The desired direction of this chart is up because we want to have as many surgical cases between infection rates. And when this converts to a statistical process control chart, it's actually a G chart that you use. With this type of chart, it can be quite difficult at times to find the actual number of operations or the number of interventions that have occurred between an incident. So for example, finding from the 8th of January to the 19th of January, finding out actually how many operations have occurred since those two patients had an infection can be quite tricky. We're now going to do an exercise, and it's over to you to decide what type of data it is. Is it continuous or attribute data? So wait time in minutes, is this continuous or attribute data? And the answer is, it's continuous data as it's a measure. Proportion of infections, is this continuous or attribute data? And the answer is, it's attribute data as infections are seen as defects or non-conformities. Height, is it continuous or attribute data? And the answer is, it's continuous data as it's a measure. Percentage of seclusions, is this continuous or attribute data? The answer is, it's attribute data as seclusions are seen as a defect or a non-conformity. Number of surgical cases, is this continuous or attribute data? It's continuous data as it's a measure of throughput. So waiting list in weeks, is this continuous or attribute data? This is continuous data as it's a measure. Percentage of venous thromboembolisms. Is this continuous or attribute data? It's attribute data as VTE or venous thromboembolism is seen as a defect or a non-conformity. Emergency department throughput. Is this continuous data or attribute data? The answer is it's continuous data as throughput is a measure. Falls per 1,000 occupied bed days. Is this continuous data or attribute data? The answer is, it's attribute data as fall is seen as a defect or a non-conformity. And number of urinary tract infections. Is this continuous data or attribute data? And the answer is, it's attribute data as UTIs are seen as defects or non-conformities. For your information, these are the references that have been used to inform this presentation, particularly the 3 books highlighted in the images. This is the end of this section in the Run Chart education session. Please go to the next part of the Run Chart series to learn more and to complete the quiz at the end.